Okay, so let's talk about rounding off numbers. Now, why do we do this? Why do we round off numbers? Well, we do this in a situation where you do a calculation, let's say, and you end up with an answer which gives you more digits than you should get to reflect the correct level of precision. So what we have to do very often is that we need to drop some of these digits so as to express the number to the correct number of significant figures. So when these digits are dropped and the value of the last digit retained is determined, this is what rounding off is all about. So there are two rules for rounding off. First rule says that when the first digit after those you want to retain is 4 or less, that digit and all others to its right are dropped, and the last remaining digit is retained unchanged. So, for example, let's say we want to round off 80.873 to 4 significant figures. Well, that means that we'd have to drop the 3, which is obviously 4 or less. And when we drop that, we simply write down what remains, and that will be the answer. All right? Here's another example. Let's say we want to round off the given number here to 4 significant figures, which means that we need to round it off to where this 5 is. That means we have to drop the 3 and the 7 and the 7 here. The 3 to be dropped is 4 or less, so therefore we keep the 5, and in fact we keep all the digit that remains, and therefore we end up with the answer being 1.875. So that's basically rule 1. Now rule 2 is slightly different. Rule 2 says when the first digit after those you want to retain is 5 or greater, then that digit and all other to its right are dropped, and the last digit retained is increased by 1. And here's an example of this. So let's say you want to round off this number to 5 significant figures, which means that 1, 2, 3, 4, 5, we need to drop this 7 and we need to drop this 2. So if you drop the 7, which is obviously greater than 5 or 5 or greater, that means that we drop the 7 and the 2, and the 6 here is increased by 1, and we end up with this answer, which is 5.4597. All right, so those are the rules for rounding off. Now we're going to see later on how do we determine to what extent we round off, and that is what the next topic is all about: significant figures in calculations. How do we deal with that when we're doing calculations? So the first thing we need to understand is that whenever you do any calculation, the results of the calculation can be no more precise than the least precise measured value involved in the calculation. That's the overriding rule for determining the extent to which you round off your final answer. So there are two situations that we're going to look at. The first is where we either multiply or divide measured numbers, and then later on we're going to look at what happens when you add or subtract numbers. So in the case of multiplication or division, the final answer that you end up with must contain the same number of significant figures as in the measurement involved in the calculation that has the least number of significant figures, right? So what that means is that if you're multiplying 2 or more numbers, what you have to do is look at the number of significant figures involved in the numbers that are involved in this operation, and then whatever answer you get on your calculator display, you round off to the lowest number of significant figures of the numbers involved in either the multiplication or division operation. So to illustrate this, let's look at this example. We're multiplying these two numbers. We're assuming that these numbers are measured values. 190.6 times 2.3. Now, if you punch these numbers into your calculator and multiply them, this is what will come out on your calculator display. All right. Now, the question now becomes, to what extent do we round off this final answer? And according to the rules that we just covered, we have to look at the number of significant figures expressed in the numbers involved in the calculation. This number, 190.6, has 4 significant figures, and the 2.3 obviously has 2 significant figures. So according to this rule, your final answer must be rounded off to 2 significant figures. So we have to round off the 438.38, which is what you get on your display, to 2 significant figures, which means, of course, we have to drop this 8, this 3, and this 8. And because the first digit to be dropped is 5 or greater, that means that this 3 has to be increased by 1 to 4, we have to replace the 8 with a placeholder 0, and therefore the answer becomes 440, or if you prefer, you can write it in scientific notation, which is 4.4 times 10 squared. All right, so that's basically how we round off when we multiply. All right, now, or divide, I should say. So the next part is where we're going to look at when we add or subtract. Now, again, what we said before is true. Whatever the final result is, it must reflect the lowest precise number involved in the operation. Now, when it comes to addition and subtraction, basically what we have to do is round off the final answer according to the number involved in the addition or subtraction that has the highest placed last significant digit. All right, so as an example, we're going to look at the addition of these three numbers. Now, if you compare these numbers, what you'll notice is that the one that is least precise is the 129, and the reason why is because the last significant digit here is in the unit place. In the case of 52.2, the last significant digit is in the 10th place, and in the case of 125.17, the last significant digit here is in the 100th place. So of these three numbers, the 129 is the least precise number, and therefore you have to round off your answer, in this case, to the unit place. Now, to give a pictorial representation of how we round off, all we have to do is set up the numbers like this, and we draw a line like that, and basically that line shows you which is the least precise number and the extent to which you round off your final answer. So therefore the least precise number is the 129, and therefore your final answer must be rounded off to the same extent. So therefore it must be rounded off to the unit place, and therefore the answer would be 306. So that's the answer right there. So that's basically how we deal with addition and subtraction. All right. Now, what if it's a multiple operation kind of situation? So let's say, for example, you're given this setup and you're asked to determine the final answer to the correct number of significant figures. Well, this is a bit more complicated because the top part is a subtraction for which the rules are different when it comes to rounding off compared to what result when you do the division, right? So basically what you have to do is do each part separately, round off appropriately, and then move on to the next part. Now, if you put all these numbers and this operation here, you're going to get this as your answer on your calculator, all right? So we have to somehow determine to what extent we round this answer off. So what we do is we do the top part first, the 1.039 minus the 1.020, and the answer we're going to get is 0.019. And of course, the answer here would be rounded off correctly because the last significant digit here is to the 1000th place, which is the same as the last significant digit here and here. So therefore, this is the answer when you do the top part. It turns out that this number is also expressed to two significant figures. So that means we have to now divide this number by the denominator down here. So when we set it up, this is what you get on your calculator screen. Remember, when you're dividing or multiplying, you round off your answer to the lowest number of significant figures of the numbers involved in the operation. So in this case, we have two significant figures here. We have four significant figures here, which means that your answer that you get here must be rounded off to two significant figures. So this is the answer. We have to drop all these digits here, colored in pink, and therefore your final answer is 0.018. And that's basically how you deal with it. All right, so that's it for now. The next video we'll be dealing with the metric system, so we'll talk about that at that point in time. So until next time.